Here is a question. In your project, the rule for publishing an article lives in 4 different files. A bug report comes in. Which of the 4 files did you forget to fix? This happens all the time, and it starts with a very reasonable decision. You built a publishing website. Someone clicks the publish button in the browser. So you wrote the publishing logic right there, inside the code that answers that button. It worked. Then you needed a scheduled job to publish articles during the night. Then you needed a command line tool. Then a webhook, which is a message that another company's server sends to yours. Every time, you copied the same logic into the new place. Now that logic exists in 4 copies. And last month, someone fixed a bug in 3 of them and forgot the 4th.
Before we fix anything, let us give this problem its name. This is not a database problem, and it is not a problem with your framework. This is application architecture, and inside application architecture, it is one specific question. Which kind of code is allowed to live in which file? Most people call this layering. There are 3 places where code can live: the handler, which talks to the web, the service, which holds your rules, and the repository, which talks to your database. And there are 3 questions about those 3 places. Which one is allowed to use which? Where does the database transaction start? And which of them can you test without starting a web server? You only feel this problem when your system has more than one way in. With one web endpoint, you will never notice it. You already have 4.
You may know the first idea by a different name, single responsibility, from Solid. It is the same instinct, but Solid is about the shape of one class. This is about the shape of a whole codebase. Here's the difference using one function. Imagine a function that makes a cup of coffee. First, the function looks at the buttons on the machine to see which cup size the customer chose. Then it decides the recipe. A large cup gets 2 shots of coffee, and if the customer comes here often, that customer gets 3 shots instead of 2. Then the function opens the bean container and takes out the beans it needs. So this one function does 3 different kinds of work. It reads the buttons, it decides the recipe, and it takes beans out of storage. Solid tells you to split this into 3 classes and give each class one job. So you do that. Now look at what did not change. The recipe class still talks to the database by itself, and the button class still adds the extra shot because the recipe class does not do it. Layering asks a different question. Which class is allowed to know about what? The button class is not allowed to know the recipe. The recipe class is not allowed to know where the beans are stored. It only asks for beans. When you keep that rule, the phone order and the morning timer can make the same cup of coffee with the same recipe.
Look at the shape of the problem. On the left, 4 ways into your system: a web request from a browser, a cron job, which is just a program your server runs on a timer, a command line tool you run by hand, and a webhook, a message another company's server sends you. 4 different doors, all wanting the same thing: publish this article. On the right, 4 separate copies of the same 6 steps. When you fix one, nothing in the code tells you the other 3 exist, so the fix goes where the bug report pointed, and the other copies quietly drift.
This is the code. It is a web endpoint, the function that runs when someone sends a publish request. Line 3 loads the article from the database. Lines 4 and 5 refuse the request if the article does not exist or if it is already published. Line 6 stamps the publish time. Line 7 saves. Line 8 clears a cache. Lines 9 and 10 email everyone who subscribed. Line 11 builds the answer. 11 lines, and every one of them works. That is exactly why nobody touches it. It is not broken. It is just the only place this knowledge lives, and it is welded to the web.
Now the same 11 lines, colored by what they actually do. Blue is talking to the web, reading the request, returning a status code. Orange is deciding, is this allowed and what happens next. Green is reaching outside, to the database, the cache, the mail server. 3 lines of web, 3 lines of decision, 5 lines of reaching out. 3 completely unrelated jobs sitting in one function, in whatever order you happen to type them, and nothing in the file marks the boundaries. That is why copying it felt fine. You could not see that you were copying 3 different things at once.
So here is the second question, and this one catches good engineers. You read about layers, you make a services folder and a repositories folder, you move code around. Did any logic actually move? Very often the answer is no. The new service just forwards. Ask it for an article, and it asks the database and hands the results straight back. Ask it to save, and it saves. Every real decision is still up in the web handler. You now have 3 files instead of 1. The same rule in the same wrong place, and a folder structure that makes you feel like the problem is solved. Here is that pass-through, honestly written. Get calls the database and returns. Save calls the database and returns. There is not a single if statement in the whole class. So here's the test. If you deleted this file and called the database directly, would anything behave differently? No. Then it was never a layer, it was a redirect with extra typing. A layer earns its place by owning a decision. A folder does not create a boundary. What creates a boundary is knowledge that lives on one side of it and nowhere else.
This is the real move. One function, publish article. Read the comment on top. No web code in here and no database code in here. It is handed three things: a place to load and store articles, something that sends notifications, and a clock. Then it does the only job it has. It decides. Missing article? Refuse. Already published? Refuse. No title? Refuse. Otherwise, stamp the time, save, notify. And look closely at what it raises when it refuses. Not a 404. That is a web answer, and a cron job at 3 in the morning cannot answer a web request. It raises its own error, in its own vocabulary. Article not found. Already published.
The other half of the move is the repository. Repository is just a name for the one object that knows how to talk to your database about a given thing. All the queries live here, and nothing else does. Get an article. Save an article. Find the ones that are due to be published. Notice how they are named. Due for publish, which is the question your program actually asks, not select where scheduled at is less than. The name describes the need, not the query. That is what lets you rewrite the query, add an index, or move to a different database without one line of your rules changing. And now the doors. The web handler is 5 lines. Take the request, call the service, turn the answer into a response. If the service says already published, that becomes a 409. If it says not found, a 404. That translation is the handler's entire job, and it is the only place in the whole codebase that knows what a status code is. Underneath it, the cron job. 2 lines. It asks the repository which articles are due, and it calls the exact same function. No copy, no paste. Same rule, running from a completely different door. So 1 job each. The handler turns the outside world into a function call and errors into status codes. The service holds the rules, and it is not allowed to know about the web or about the database. The repository holds the queries, and it is not allowed to know about the rules. And there is one thing here that matters more than the folder names. The arrows only point down. The handler calls the service calls the repository, never the other way. A repository that reaches back up into your rules is not a repository. It is the same tangle wearing a new name. Here is the payoff, and it is something you can actually feel. A new rule arrives. A premium article now needs an editor sign-off. Before, that is 4 edits in 4 files, 4 reviews, and 4 chances to miss one. After, it is 1 function in 1 file, and every door, the website, the timer, the command line, the webhook, picks it up for free because none of them was ever holding a copy. 1 place to change, 1 place to test, 1 place to trust. 3 numbers hold the whole argument. 4 copies of the rule before, 1 file that owns it after, and 0 lines of database code inside the service. That last one is the one people skip, and it is what keeps the other 2 true. The moment a query leaks into your rules, the rules are pinned to that database, and the whole thing starts sliding back. So split by job, not by habit. The handler turns a request into a call, and an error into a status code. The service holds the rules, and it may not know about the web or the database. The repository holds the queries, and it may not know the rules. And the last one is what saves you from the trap. If a layer only forwards, delete it. It is not earning its file. Layers are not about having more folders. They are about every rule having exactly one home. If that made the 3 layers click, hit like and subscribe. One concept all the way down to the code, every time.